So the test looks just like the problems are almost exactly the same. Different functions, different points of intersection. Okay, you have to tell me. So does everybody understand average means average value now? So average velocity means the average value of the velocity from 0 to 4. And here, let's write this on the board. So problem, no, you guys do have questions on number 3, believe me, you do, because every year students have trouble with this. So 3C, compute the, what the heck, let's just do all of problem 3. Well, at least set up the integral. So remember now, you need an integral and then the answer. If you just put the answer, you're not going to get all points now. Compute the displacement of the particle. Well, how do you compute the displacement? You integrate the velocity dt. See, like this is good enough because v is defined on the paper there. And then you just punch it in on your calculator. B, compute the total distance traveled. So integral from 0 to 4 of the absolute value of the velocity dt. And then punch it in on your calculator. And make sure you're in radian volt now, because that could be, if there's trig functions, you're going to get it wrong, right? C, compute the average velocity. That means the average value of the velocity. So 1 over b minus a, integral from a to b of the velocity dt. D, compute the average acceleration from 2 to 5. So 1 over b minus a, integral from a to b of the acceleration. Now the acceleration is not defined on the paper, so you're actually going to compute it, yeah? So if the velocity is, what is the velocity function? Natural log root 2 minus cosine t. How do you take the derivative of natural log box? 1 over box, so that's root 2 minus cosine t, times the derivative of the box, which is sine t. That's the acceleration. So we're computing the average value of the acceleration from 2 to 5. E, okay, this is code red. Does everybody understand when to use code red? We talked about it last time. So, you are given the velocity. In problem 3E, it says if, I can't see, x of 1 equal 2, compute x of 3. So anytime they ask you to compute something about the antiderivative of the function, isn't the antiderivative of velocity position? That's when you do code red. So what you're going to do is you're going to integrate the velocity from, what limit should I put on here? 1 and 3. One of them you know and the other one you're trying to find. So you go from 1 to 3. And then using the fundamental theorem of calculus part 2, what is the antiderivative of the velocity? Position. Plug in the top number, plug in the bottom number, and subtract. Now we already know that this is equal to 2, and this can be computed on your calculator, right? So you just have to punch it in. So compute this on your calculator, add the 2 to this side, and that's how you compute x of 3. This is simply the fundamental theorem of calculus part 2. But like I said, from now on, we're just going to call this code red. It's easier to say. And then F. When is the speed increasing? Now, the last time we had this problem was not in this chapter, it was a while back, but I put this problem on the test. Okay, for what values of t between 0 and 6 is the speed increasing? How do you tell when the speed is increasing? You guys remember?
Speed and acceleration.
When the velocity and acceleration have the same sign. How do you tell when the speed is decreasing? When the velocity and acceleration have opposite signs. So what you need to do is you need to make a number line for the velocity, and you need to make a number line for the acceleration, and you have to see where they have the same signs. Okay, I'm gonna show you, it's not a trick, but, okay, so let's get the graphic. Did you guys actually do this already? That's funny. Apps function, okay. So let's clear this up. Oh, yeah. Okay, so let's punch in the velocity function. Am I in radian mode? Yes. Natural log root 2. This is what happens when you do 3 different calculators. Root 2 minus cosine x. That's it, right? Enter. Okay, now we're gonna make a number line for that. But you know what? No sense make the whole number line. It says from 0 to 6, so wouldn't it make sense to go from 0, enter, to 6? And so that you don't have to look at other parts of the graph. And then, I guess that's okay, but I'm gonna change it. I'm gonna just go -2 to 2. Because you just need to see when the graph is crossing the x-axis, right? And then now we press plot. Oh, there you go. So where is this first x-intercept right there? So remember, put the cursor somewhere close there and then go menu, function, root. 1.144. Somebody remember that number, because I have to go onto the board. 1.144. And then this one is menu, function, root. 5.139. Gosh. 5.139. 5.139. 5.139. See, I already forgot the other one already. Something .144. 1.144. And then look, it's below, above, below. So if it's below, it's minus, above it's plus, below is minus. So that's the number line you should get for your velocity. Now, when you tell your calculator to graph the acceleration, remember this was the acceleration? So you can actually graph that, or you can just simply tell your calculator to graph the derivative of that. Remember how to do that? So like, if you don't trust yourself to compute the derivative correctly, like, for example, some of you are going to forget to multiply by the derivative of the box, and that's going to be big points. So we go back to symbolic. So F2, tell your calculator to graph the derivative of F1. So how do you tell derivative? You go to the template and select derivative. Select, okay, the derivative of, okay, now how do I get F1?
Alpha.
Can you just go alpha F1? Is it that simple?
Yeah.
Alpha F1.
Parentheses X.
Do you have to put the parentheses X?
Oh, I don't know.
Okay, parentheses X with respect to X. Okay, we'll try it. Now we only want to graph the second one, so let's uncheck the first one then. And then now plot. It worked! It worked.
What did you draw?
I graphed the derivative of velocity. Here, let's go back. Symbolic. See, see, F1 is the velocity. So isn't the derivative of that the acceleration? Yeah, so I told my calculator, graph the derivative of F1, because F1 was the velocity. Or you can actually compute the acceleration by using the, you know, the derivative of natural log box is 1 over box times the derivative of box. So it doesn't, I just wanted to show you this because you have options. Most of you probably just want to punch it in as sine x over root 2 minus cosine x. Question?
On the test, do we have to write the derivative?
No, you just have to show the number line though.
Yeah.
Would you do that for like second derivative too?
Say that again?
Would you ever do the same thing to find the second derivative?
Yeah, so then you take the derivative of F2 then.
Okay.
But then I'm not sure, your calculator might take a while to do it, because what your calculator does, it computes the slope at every point, and then it plots a point. That's what it does. So I don't know. I have a feeling your calculator is pretty fast, though. So which way do you like better? This one, or just take the derivative of the darn thing?
That.
Okay, I'm gonna go back to the graph now. So I don't care how you do it, right? I'm just giving you an option here. Just do it correctly. So plot. So the first x-intercept obviously is 0, right? Because sine of 0 is 0. But then what about this one here? Put the thing close. Menu, function, root. Oh, that's pi, 3.14. Of course, duh. Right? Isn't sine 0 at pi? Ah, we didn't even need to use a calculator for this. Well, of course, if you didn't take the derivative, you wouldn't know, right? Because here, this is the acceleration. When is this equal to 0? When the top is 0. When is sine 0? 0 pi and 2 pi, right? So 0 pi, which is 3.14159. So 3.142. And then 2 pi is 6 point, let's see, 6 point, what is 2 pi? What is 2 times this? 6.28 something. This is already past 6. We're already doing it to 6, so we don't really care about that. And what does the graph look like? Above and then below. So it's plus here and minus there. So I forget the question already. Oh, the thing is blocking. When is the speed increasing? When the velocity and acceleration have the same sign. So look, where do they have the same sign? Between 1.144 and 3.142. And then they're both negative over here, so between 5.139 and 6. How come it includes 6? I probably won't take off a point for that. In fact, I'll tell you right now, on the AP exam, whether it's a parentheses or a bracket, they don't care. They give you the point, no, either way. Because they don't want to take off a whole point. Because we don't take off fractional points, we take off whole points. They don't want to take off a whole point just because you don't know the difference between a parentheses and a bracket. But this is the correct answer. Is that the answer on the bottom? So that's what you gotta do. You gotta make 2 number lines now. All right. Let's move this out of the way. Just minimize that. Okay. Do we have problems with anything else? Now is the time to ask. I don't know what problems I have, Mr. Park. I gotta actually do it yet. Exactly. Number 4. The fundamental theorem of calculus, part 1. Hey, that reminds me. I haven't danced in a long time. Have you? Because of the pandemic? I wouldn't have been dancing anyway, but. Number 4. I was thinking we should put something down in the video. Maybe we should make a dance for Tapper and Tom.
Yeah.
What's a good dancing song then?
Dancing Queen.
No.
I can play it. I can play it right now.
That's the
Name
Jump
the song,
dancing
and I
song.
will play it.
I heard something on the radio going home one day. I didn't know who that was.
What is it called?
Dua Lipa. And what was the song?
Break My Heart?
Is it a fast song?
Oh, here, wait.
I can't really do it unless I have music.
Is it this one? Oh my god. So we have to go to the chorus.
No, that's not the one.
Which one is it?
No, I'm so tired, I gotta get off. Oh my gosh, why do I do this? Why? Tapper, that was for you and Tommy. I dedicate the dance to you. This is like running up the stairs. Okay, how do you find length of curve A to B, look, I just looked at it and I forgot. Negative 1 to 4 of the square root of 1 plus the derivative squared. Right? Now, how do you take, whose idea was that? How do you take the derivative of a function that's an integral? You use the fundamental theorem of calculus, part 1. Make sure the lower limit is a constant, which it is, and then you take this top thing and plug it in for t here. So you're going to get the square root of 2 plus cosine x squared. And then what's the most important part? You got to multiply it by the derivative of this, which is 2x. If you don't multiply by the derivative of that, fatal error. I'm guessing each integral is going to be worth, each problem is going to be 5 points. So if you take the derivative wrong, I don't think they can give you partial credit for that. And then now just punch this in on your calculator, and then you should get the answer. So it just depends how the function is given. Okay, so what if I give you a different function? Like what if I say, okay, I don't want to test you on the fundamental theorem of calculus part 1, even though I want to. What if I just give you a regular function? Let me think. What's a regular function?
X squared X.
No, not that regular.
X plus
No, something where, here, I got a good one. How about x
plus 1.
cosine 3x?
Oh, that's not.
Yeah, that would be good. Okay, so then, let's say we use the same limit. So integral from x1 to x2, square root of 1 plus the derivative squared dx. All you have to do is put the derivative in the parentheses and you're in the money. How do you take the derivative of this? Should I make up my own rule?
Tabular. Not tabular.
Okay, let me put, again, okay, time out.
Product.
After you cover up your nose and put your shield down. There is no more tabular.
Oh.
There's no tabular in it. Erase it from your memory until after the AP exam. If anybody says or does tabular in this class, I don't know what I'm capable of. Maybe something dangerous. No more tabular.
Integrating by parts.
Bro,
No more
that's the
integrating by
same
parts.
thing.
No derivative. You have to do product rule.
No, you're taking the derivative. So, okay, thank you. You use the product rule.
Oh,
Wait,
No,
what?
no, every year there's people that do tabular, but I'm telling you explicitly, never use tabular again until after the AP exam, okay? It's gone. We're not doing it already.
Which one is tabular?
Oh, no, that's a good one. That's a good one. You don't want to know. Okay, but I'll tell you. That's where you want to take the antiderivative of, for example, you have the integral of this. Remember tabular, you go x1, 0, cosine 3x, 1/3 sine 3x, negative 1/9 cosine 3x, tic-tac-toe, like that. That's tabular. No more though. Don't ever do that again until after the AP exam. Okay, so how do you take the derivative of this? You use the product rule. Derivative of the first, leave the second one alone. Leave the first one alone. And what's the derivative of cosine box? Negative sine box times the derivative of box. Or maybe tomorrow I give you something with a quotient, so you gotta use quotient rule. Have we forgotten that? Let's review it.
High D low, low D high.
Minus high D low all over derivative.
Okay,
Something
let's try.
squared we
Okay,
get.
so what if I give you the function? I forgot what's on the test already. I made it. Okay, what if it's something like this? How about x squared over
2.
x cubed plus 5 or something?
Wow.
So you would go integral from a to b, square root of 1 plus the derivative squared dx. How do you take the derivative of that? You use the quotient rule. Low
D high.
d high minus high d low all over denominator squared we go. And then punch it in on your calculator.
Oh, that's
Well, there's only 3 things you're gonna do, right? Either it's a simple derivative, or it's a product rule, quotient rule, or fundamental theorem of calculus part 1. and then water flows into it, but then water's flowing out of it. How much is in the tank at the end of whatever? I think you guys can do that one, right? What about cutting? Okay, you know what? You guys gotta tell me if you have questions. Tom, Tepper? Oh, no questions from them, I guess.
Oh, I have a question.
Huh?
Number 7.
Number 7, the position of a, okay, there you go. Number 7, the position of the particle is given by the equation. So that means it's moving on the y-axis, so it's going up and down like this. Gosh, I can't say it. 1, 6. Hey, that's really good exercise, Nancy. I really need to do that more. T squared plus 2t minus 3
Plus cosine
t over 2. Okay, so that's the position. What is the particle's velocity when the acceleration is 0? So how do you, if you know position, how do you get velocity? Okay, so you gotta take the derivative. See, again, you gotta take derivatives, right? So again, you gotta know when to take derivatives and antiderivatives. So 1/2 t squared minus 2t plus 2, that's 0, and the derivative of cosine box is negative sine box times the derivative of box. And then the acceleration is, take another derivative, so put the 2 in the front, t minus 2, the derivative of 2 is 0, and the derivative of sine box is cosine box, so it's going to be cosine box times the derivative of box, which is 1/2, so that makes that a 1/4. So it says find the velocity when the acceleration is 0. So here's the acceleration. How do you figure out when it's equal to 0? You solve this equation on your calculator. How do you solve any equation on your calculator? You make one side 0, which it is. You graph this and see where it crosses the x-axis, yeah? Should we do it on the screen? What? Okay, let's see if I can read that from here. Henry, are you in radian mode? Okay, that's not the problem then. Okay, so symbolic, let's get rid of all of this. Shift clear. Yes. Okay. X minus 2 minus 1/4. I'll just put 0.25 cosine t over 2, so x over 2. X over 2. Outside click, enter. And why don't we just go with the, so when you go to plot setup, do you guys remember how to do it? Send it to the initial factory settings?
Shift clear.
Shift clear. And then press plot. So it crosses the x-axis right there. So put the cursor somewhere near there. Menu, function. Okay, so what you need to do now, it says you have to find the velocity at this time. So you have to take this number with all its decimal places and plug it into the velocity equation. So, you guys want to copy? I still never learned to copy and paste yet. So you know what I'm going to do? I'm going to go to home. I'm going to press X, enter. See how that number, it gets stored into X once your calculator computes it? And then now I'm going to store this into, where's the store button? Oh, it's right here. Store this into any letter you want. I'll go alpha A then. Enter. So take this number and plug it into the velocity equation. So what's the velocity equation? 1/2, I'll just put 0.5 x squared minus 2x minus 2, where's the x? Oh, right there. 2x plus 2 plus 2. I think it's easier to do it by hand instead of using this. Minus 1/2, so 0.5. Easier to input it for me anyway. Sine of x over 2, so x over 2. Right click, and then press enter. So what your calculator, oh no, we were supposed to put A there.
Can you
yeah, you know what, we still can do it because x, this number is now stored in x, yeah?
Yeah.
Oh, so we didn't even have to store it into A. Yep, there's your answer. Is that the answer on the bottom? Negative 0.429? Make sure you use all the decimal places though now. Do not round off until you actually have to give your answer,
Yeah, that's the answer.
okay? Anyway, that's how you do it. How do you solve any equation on your calculator? You make one side 0, graph it, and wherever it crosses the x-axis, those are your answers. Okay, and then
Can you do number 6, please?
number 6. Oh, dividing it into 2 equal parts. Okay, well, I know this problem is on the test because I wrote it this morning. Plus, I pretty much give the same test every year.
What's like the
No.
average between the other?
Oh, no, usually, well, I don't wanna say anything, but usually this test is pretty good. I think last year the average was like 80, high 80s or something.
80.
That's because you don't have to worry about memorizing any antiderivatives, right? You're just computing all the integrals on your calculator, right? You just have to worry about taking derivatives, that's what you need to worry about. No, we're doing number 6 full. R is the region bounded by y equal cosine x and y equal x and the y-axis. So if you graph this on your calculator, it's gonna look something like this. So cosine x looks like this, y equals x looks like that, and then the y-axis is here, so this is the region. Bounded means enclosed by. Now it says R is divided into 2 regions of equal area by a vertical line like this. We've done this problem before, right? X equal K. Find the value of K. So how did we do this problem before? Compute the area of the shaded region. So what you need to do, the first thing you need to do is find where they intersect. It's not gonna be something nice. Do not try to guess and check. You're gonna have to use your calculator to do it.
What's your part? Or
Yeah.
like the graphing one where you, or like where you take the intercept and stuff?
That's to solve equations.
No, like do you need to take or like store the value, or can you just?
Well, it depends. If you're gonna use it in another computation, then you need to store it or use all the decimal places.
Could you use like just the first 3, or you have to store?
No. Okay, if you wanna be correct at 3 places, then you should use at least 5. Well, I mean, what the heck, you got your calculator, just store it, and then you got like 8 decimal places, right? Like, I'm just gonna do it on my calculator so I don't have to walk back and forth. So cosine x, and the other one is x. Graph. I don't like this one. Zoom 4. I like that one better. Okay, so where do they intersect? So my calculator, I gotta go calculate intersection point. Okay, so this is point, gosh, I can't even see this without glasses. 739.08513. That's what I think I'm reading. I can't believe my eyes are that bad. Okay, I think that's right. And then store it. You don't have to store it, but like I said, you better use at least 5 decimal places if you're not, just don't round it off to 0.739. I mean, you might come out with the correct answer, but you're playing with fire.
Wait, how do you store it?
Well, okay, let's do it on your calculator then. You see this button here? See? Anytime your calculator computes something, you can store that number into any letter you want, A, B, C, all the way to Z. Or you can just copy and paste all of them. But like I said, I haven't learned to do that yet. So symbolic. Shift clear. Whew. Okay, so we want cosine x, enter, and then x, enter, and plot. So we want to know where they intersect. So put the cursor there, menu, function. intersection. What the heck is this? I guess with F1 then. There you go, 0.73909. So that number is now stored in X on your calculator. So what I like to do, I don't know if you need to do this. Go to the home screen. If you press X, enter, see how that number pops out with all the decimal places? Then you press store, which is the thing there. Store, and then just pick any letter from A through Z. Alpha A, enter. So now, that number with all its decimal places is stored into A now.
When we're showing our work on a test, we have to like, do we just like
Did you do this?
A to B or something?
If you show that on your paper.
Oh,
Yeah, so anytime something is written on your paper, like if you put, okay, like if you said, this is equal to A, then you can just write A after that, as long as it's defined on your paper. Okay, so the first thing you want to do is find the entire area. So how do you find the entire area of the shaded region? The integral from 0 to A of top minus bottom. Please go top minus bottom. Some of you are still going bottom minus top and left minus right now. It's top minus bottom, right minus left. Top minus bottom dx. Okay, punch this in on your calculator, and you know what I would do? Whatever number you get, store it into B, or pick a letter. Okay, so how do I get this line here that cuts it exactly in half? So the integral from 0 to k of top minus bottom has to equal to half of the area. So since, here's the area, so B over 2, right? Now, there's two things you can do here. I didn't know your calculator could do this, because some calculators can't do this, but last year they told me, Mr. Park, we just did this. Okay, so one thing you can do is, how do you compute this integral right here? You find the antiderivative of this. What is the antiderivative? Sine x minus 1/2 x squared from 0 to k, right? Plug in the top thingy. I'll do it over here. So you get sine k minus 1/2 k squared minus, plug in the bottom, which don't assume it's 0 now. And that is equal to B over 2. Remember, B is this area of the whole thing we stored, yeah? Now, we're solving for k. How do you solve any equation on your calculator? You make one side 0 and you graph it. So what you do is you make one side 0 and you graph it. So what do you graph? You go graph y equal sine x minus 1/2 x squared minus b over 2. Graph that on your calculator. Wherever it crosses the x-axis, that's going to be your answer. Now that's one way to do it. But you know what I found out?
No.
You can just do it like this. You don't even have to do the antiderivative. Just punch in on your calculator this, the integral from 0 to x, because you got to put x there, because that's all your calculator knows, of cosine x minus x dx minus b over 2. So how do you solve any equation on your calculator? You make one side 0, so you bring the b over 2 over, graph it, and wherever it crosses the x-axis, that's your answer. So you can just punch it in like this. You don't even have to compute an antiderivative. Okay, I never tried this on your calculator, but when I do it on mine, it takes a really long time. So let's see how it works for yours. Okay, symbolic. Okay, so template. Where's the template button? I need integral. Okay, integral from 0 to x. 0. And then this is parentheses cosine x minus x decimal places? Okay, that's okay, I'll just do it on this calculator. Math, this calculator got it. Wait, I gotta check. Yes, but I'm in radian mode. Cosine x minus x from 0 to 0.739, oh, dummy, 0.8513. I get 0.400488, and so if you divide that by 2, you get 0.20024436061.
Wait, how come we're graphing it and not just like solving for that?
Yeah, that's what you're doing. That's how you solve equations on your calculator. You make one side 0, and you graph it. And wherever it crosses the x-axis, that's the answer. That's how you solve any equation on your calculator. Make one side 0, so minus 0.20024436061. Okay, now plot it. Whoops, what's happening? Not the number. What the heck?
Yeah, mine isn't graphing.
Yeah, mine is not graphing either. What's happening? You need another space?
How do you
How's it going?
How do you space? This is space?
I think mine looks like that, but
Okay, let's try it now. No? Still not graphing?
like for 8, like for 2.
Well, we used to be able to do this with the prism, Casio prism.
Oh, sorry, I don't know what it is.
Okay, well, if that doesn't work, then you just gotta do it the way I showed you the first time. Compute the antiderivative. And don't worry, because I'm not gonna give you something where it's a difficult antiderivative. So then you have to do this. You get this equation. How do you solve any equation on your calculator? Make one side 0, graph it, and wherever it crosses the x-axis, that is the answer. Yeah, so I guess, like, did anybody get it to work? Lee, did you get it to work? This way? This way. Yeah, just do it though, yeah. But I know it works. They told me they did it last year, but whatever. It's not that difficult.
I just picked this reason.
Okay, whoop. Any other questions? Okay, I just want to practice one thing because I'm not going to tell you how to do it. Everybody do this, because this problem is on there tomorrow. Okay, give me a function. Let's say f prime of x is equal to, I gotta give you a function where you cannot find the antiderivative. Like, how about 3 sine x squared plus 5 or something? If f of 1 equals 2, find f of 4. What do you do? Code red. The fundamental theorem of calculus part 2. See, you're given a function and they're asking you to find something about its antiderivative, right? Isn't f the antiderivative of f prime? So this is the fundamental theorem of calculus part 2. So what you do is you integrate this. You integrate this from, what limits do I put on here? 1 to 4, because one of them you know and the other one you're trying to find. So 1 to 4, and what is that equal to? Well, if this is f prime, what is the antiderivative of it? F. So to compute an integral, you find the antiderivative compute that integral, oh, why did I leave my calculator? Oh, now yours worked. What did you do? How come nobody else could get it to work? Lee got his to work.
So what did you do?
He punched it in just like this. He punched it in, except of course, what is this number? 0.200, whatever it is. I don't know, he got it to work. Okay, but the rest of us, let's compute this integral. I'm just gonna use my calculator.
Wait, which one was this one? Oh, did you just,
3 sine
oh, I see.
x squared plus 5, comma 4. Okay, I get 1.264 if you round it off. So therefore, f of 4 is equal to, all you have to do is add 2 to both sides, so it'll be 3.264. So you just gotta know when to do this. You guys understand when to do it now? When you are asked to compute the antiderivative of something. We use code red. Anyway, you guys can fiddle around with your calculator to see if this works. If it doesn't work, then just do it, find the antiderivative, plug in the top number, bottom number, subtract. And set that equal to half the area, and then solve the equation. I mean, it might save you 1 minute to do it this way, but come on, 1 minute. It's not that much. Okay, let me look at this thing one more time to see if I can give you any more hints. So make sure you can compute areas. You guys know how to do that, and then you gotta be able to do slices, discs, and washers. All of them are gonna be on there, just like this worksheet here. So again, if you can do this worksheet, you should do very well on the test. That's all I can tell you. So make sure you can do this on your own now. Okay, we are ready for the test. What time is it? Do we have time to play a game? We don't want to play a game. No, let's play. We're playing a game. In fact, we'll let the people. Which game are we going to play? Let's play this one.
Just curious, Mr. Park, for calculus, are we always in radian mode?
Yes, do not ever put your calculator in degree mode. Now, people always say, "Yeah, well, Mr. Park, we put it in degree mode for physics." Okay, that's fine, but then just remember when you go to calculus, if you take the AP exam and you're in degree mode, you're probably not going to get a 5. Anyway, that's why I always plant somebody in the AP. Who wants to be the plant? Okay, we'll find somebody to be the plant. So when you guys go, I don't know, Lord Jim or Cito, wherever you're taking the test, before the test starts, somebody's going to raise their hand, and then you're going to ask the proctor, do our calculators have to be in radian mode? And then when you hear that, then you check. No, I plant someone every year.
Who's obnoxious? Me?
Oh, we got plenty of people.
Suzuki.
Okay, don't worry, we'll worry about the plant later on. All right, wait. Who won the last game?
Boys.
Yeah.
We won both games.
We did.
Okay, these are the most used letters in the English language.
Oh Lord. RST, yeah.
Did we have more girls than boys anyway?
Yeah.
Okay, so there, maybe, okay, so girls go first. And Lord did.
E.
E, be on the list, right? 13, 24.
That's so
Girls.
The candy complete.
Did someone say S?
Yeah.
Oh, that's
T.
20. That's
T.
27.
I was
I said it.
listening.
That's 27.
T.
T.
Oh, shit.
Affected consonant. T is number 2.
I'm gonna just say E every time.
Whoa.
E.
Boy, Lee.
R.
R. 9.
Oh boy. With the first
Letter letter.
Wait, are these like written or said?
I don't know.
What?
Both.
Wait, what?
The same thing.
H.
H. 8. Lee. L. 11. No one said L yet, yeah?
No.
Because that's a total. Go.
Y.
Y.
That's that right.
What?
Y. 18.
Oh shit.
What?
I said S.
Boy.
And
N. 6. The game is tightening up. Girl. Go.
Did anyone say D?
D. No. D. 10. So boys, you cannot win,
Oh, no.
right? Because you're already over 47.
I don't.
All right. ETAOINSHR. You guys got that, yeah? D, that's the top 10. LCUMWFGYPB. That's the next 10. The last 6 are VKJXQZ.
What is E?
Yeah, you guys stayed away, right? You guys did pretty well. All right, the bell's gonna ring in a minute. Okay, Mike. Tapper and Hub, did you guys play along?
I hope they did.
No. What am I here to entertain you?
Yeah.
No. It's not a dance at your whim.